All right, welcome to the Chapter 4 practice test for college algebra. The first question asks us to find the domain of the function. Domain is the x value, so we want to know what x values work in this function. Since it's a square root, we know that we're not allowed to take the square root of a negative number. So what I need to know is when the inside of this function is equal to 0, and that'll be the last number that I can use. So quickly I figure out that negative 4 plus 4 is equal to 0. So negative 4 going into the function would make it 0, and I can take the square root of 0. So I think about a number line, and I put negative 4 on the number line, and negative 4 is a solution to this problem. Now I think, can I put in numbers larger than negative 4 or smaller than negative 4? So if I put in like 1, 2, 10, 20, 30, I can put bigger numbers in. So like say x is equal to 5, right? 5 goes into the function, and 5 would go in here, right? And so 5 plus 4 is 9. I can take the square root of 9. So it's things that are larger than negative 4 that work. So anything bigger than negative 4 works in the equation. So I'm going to write this in interval notation. So I do bracket and negative 4 to positive infinity. So this interval notation here matches this graphing on the x-axis. So I just want to know about the x values. Also, you can graph this on the calculator, and I did. And I can see literally that this is things that are bigger than negative 4, because right here is negative 4. So right there, that's supposed to be an arrow, that's x equals negative 4, and it's everything above negative 4 works. Question number 2 is a domain question. This time we want to know what works and what doesn't work, the domain of the function. This time we're interested in division by 0. I'm not allowed to divide by 0. So what I do is I set the bottom of the fraction equal to 0, and quickly I can see that x equals plus or minus 5. That's when if I put those in, then the bottom of the fraction, the denominator is equal to 0 when it's plus or minus 5. So I'm going to think number line here. I'm going to put negative 5 on the number line in an open circle because it cannot be negative 5. I'm going to put 5 on the number line, put an open circle, and it can't be 5, positive 5. But what about all the numbers in between those and outside of those? Well, if I put in large numbers like 10, 20, 30, that would be okay, wouldn't it? I'll go green here. So if I put 10 in here, that would be 100. And minus 25 is positive, so anything bigger than 5 would work. If I put in something like 0, then that would be 0, and then it'd be 8 over negative 25, which would also work. And if I put in big negative numbers, it would also work. So everything works except for 5 and negative 5. So to put this in interval notation, you would do left parenthesis, negative infinity, comma, negative 5, parenthesis, union, and then everything between negative 5 and 5 works, and then union 5 to infinity. So this interval notation right here matches, and I'm using parentheses because you cannot touch negative 5, and you cannot touch 5, and you can't touch the infinities either because you can never reach infinity. Also, you can look at the graph of this, and I did that. I typed this into the calculator, and this is what the graph looks like. And you can clearly see that when x is negative 5 and 5, it creates the vertical asymptote. So right here and right there, it cannot be 5 or negative 5. It breaks up the function into 3 parts. The parts that are smaller than negative 5, between negative 5 and 5, and greater than 5. All right, number 3. So this one here, we're just filling out the information. What's the range of the function? The range of the function is the y values. So we just list in the y values here. Let's see, y values. The biggest y value is 5. So I get my marker back up here again. The greatest y value is 5, and the lowest y value is negative 3. So that's the range of the function between those. So the answer is -3 to 5. Oops, I need a bracket on that because it does go all the way up and touch 5. So that's a mistake. You need the bracket there. So it touches those. And blue, oops, there we go. 5 and bracket. Okay, where is it cross the x-axis, the x-intercepts? You can clearly see. Oh, whoa, my vision's off here. This needs to go right here. There we go. Skipped a problem, didn't I? Okay, the maximum, the local maximum is this point right here. The highest point is 5. So it's going to be 5 when x is equal to 2. The x-intercepts are -3, -1, and 4. That's where it crosses the x-axis. And then when y is -3, because that's what this means, when y is -3, that'd be a horizontal line -3. What's the x value that goes with that? So we go across here, and the answer is 5. So right there at 5 is where it hits. So the answer is 5. Intervals of decrease. This is when it's decreasing. It's decreasing on these two intervals. So I'm going to go to the highlighter tool, and it's going down on this interval, and it's going down on this interval. So those two intervals is where it's going down. So when you list that out, you list the x values for that. So it's between -4 and 2. So that's this first one here, -4 and 2. And then the second one here is between 2 and 5. So we just say 2 to 5. So that's listed in interval notation. Okay, odd, even, or neither. So if you put -x into the function and it returns back the function, we say that that function is has y-axis symmetry and it's an even function. So we have two names for it. So if I put negative x in and raise it to the 4th power, and I take negative x and put it in, raise it to the 2nd power, plus 6, that's just going to yield the original function. Raising a negative to the 4th or a negative to the 2nd power, it just goes back to the original. So it's x to the 4th minus 5x squared plus 6. So it follows this pattern right here. Well, that means that it has the y-axis symmetry, or that it's even. So this is an even function. All right, now if we go and type it into the calculator and graph it, you can see that it's an even function, and I did so. So it makes this down and up and down and up motion. Looks like a W or 2 U's smashed together, or 2 parabolas smashed together, or whatever, but it is symmetrical with respect to the y-axis, and it follows that rule. When you take negative x and put it in, you get back the original function. So that's the situation there. Now, if you put in negative x and negative y, then it has the origin symmetry, which means it's an odd function. So if you replace negative y with y and replace x with negative x, and then it goes back to y equals x, right? So you take out y, you put in negative y, you put in negative x instead of x, and then you simplify it, and it goes back to the original. Then it has origin symmetry, or it is odd or origin symmetry. Okay, number 5. You're supposed to describe what happened here. Remember, this right here moves the original function 3 spaces to the right, so it's 3 right. You got to think backwards when it's inside the function, and then up 2. And again, if you're not sure of this, look what we just did here. I typed it into the calculator, and you can clearly see that the blue function moved 3 spaces to the right and up 2 spaces. Number 6, we're supposed to write the equation of the secant line between 2 and 5. So here's 2 right here. Let's see, let me get back out of this, and here and here. So there's 2 and there's 5. So we're going between those two. There would be the secant line. I just need to write the equation of that. You don't really need to do a lot of calculations with this. You can just kind of read the graph. That's one of the reasons why I did this. So if I put in 2, I get back 0, because that's the point 2, 0. If I put 5 into the original equation, I get back 3, I believe, isn't it? Yeah, it's 3. So if I put in 5, I get back 3. So the change would be the change in y over the change in x, which is 3 over 3. So the change is 1. And you can see that the function goes up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. I mean, the secant line goes up 1 over 1, up 1 over 1. So the slope of the secant line is equal to 1. I just got to write the equation. You can even see that the secant line comes down and crosses at -2. So if you're not super confident in that, you just do y is equal to mx plus b. I know that y, I'll use this point right here, y is 0, the slope of my secant is 1, my x is 2, and b is b. Then you can algebraically solve for b. So 0 is equal to 2 plus b. Subtract the 2 over, -2 is equal to b. And I already showed you that it was -2 because, look, it's right there, -2. That's where it crosses. So the equation of the secant line is y is equal to slope of 1. You can write 1 or not write 1. X, not m, x, 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 x. X, and then -2. So that's the equation of the secant line, which shows us the average rate of change over that interval. So it's changing at a rate of 1 over that interval. So my analogy was this, is the blue line represents like a straight road and the black curve represents a curvy road. We just made it go straight. So the average change over that interval is that straight line. And it is changing at a rate of 1. Okay, number 7, we have to do these drawings. The first one, you can't type these into the calculator. So the first thing that you have to do is make the whole thing do this right here. And what does this say? Make the whole function go up 3. So what I do is I just find the points right here. I'm going to use this point first, and that would be 0, 3. So now it's 0, 6. So I go 1, 2, 3, 4, 5, 6. All right, and then this point over here is opposite of it, and that's 7 over. So it'd be 7 over and up 6. Let's see, 1, 2, 3, 4, 5, 6, 7, up 6 would be right there. And then these points are over 3 and over 4. So it's a slopey down thing like this. So it's over 3, over 4, and then like that. So that should be it. That's the deal with that one. It goes up 3 spaces. You could even draw all this in like so, and then just take your your smartboard and make it go up 3 spaces, right? So there it is. All right, the next one is the tricky one where you got to do 2 things to it. Okay, there we go. So we have to do 2 things to this, so I'm going to do it in 2 steps. So the first thing that has to happen to this is it's going to be that negative x there flips it over the y-axis, right? Flips it over the y-axis. So I need to flip this over the y-axis. So this is going to be down like this, over 1, and then up like that. So there it is. That's the first step. Now it's going to be flipped over the x-axis and stretched out by a factor of 2. That's what that -2 does in front. So when I flip this over, these are just going to stay right there. So that's the answer there. It's going to be flipped over and twice as much. So this is 3 high here, so now it's going to be 6 high, 1 or 6 low. 1, 2, 3, 4, 5, 6. So it's going to be stretched like that. And then the same thing's going to happen here. There's 3, and there's going to be 6 this way. 1, 2, 3, 4, 5, 6. So it's stretched like so. So this is the answer right here. All right. So that's the answer right there. It's flipped over both axes because of the 2 negatives, and then the 2 makes it be twice as much down instead of up. Okay, this is 2 spaces to the left, 2 spaces to the left, because it's inside the function. So when it's inside the function, it's left or right, and then the +2 really does mean 2 spaces to the left. So everything goes over 2 spaces. So this point right here is now over here. This point here is now right there. This point here is right there. And this point here is right there. So it's this, 2 spaces, and then up like that. So that's the answer. So I just moved all those critical points over 2 spaces to the left. Okay, here's the box problem. It says a box with a square base is wider than it is tall. In order to send the box through the mail, the width of the box and the perimeter of one of the non-square sides of the box can be no more than 108 inches. So the base is x. So the base is x, so there's that. And then the perimeter of the side. So the perimeter of the side would be 2 y's and 2 x's. So there's the 2 x's, the 2 y's, and then the base, and then there can't be any more than 108. So there's that hint equation. I gave that to you. Okay, maximum volume of the box that we want. So the volume is equal to x base, or it's the length times width times height. So it's x times y. Or volume is equal to x squared y. I cannot graph this on the calculator right now because I have too many variables. I need it to be in terms of one variable. So I need volume on one side of the equation and just x on the other side of the equation. So what do? I go over here and I have to solve this for y and plug it into my main equation. So this is the hint equation or the helper equation. So 108 is equal to 3x plus 2y. Subtract 3x over. 108 minus 3x is equal to 2y. Get y by itself by dividing everything by 2. So I get 54 minus 1.5x is equal to y. I'm going to take that and stick it in there. So I just divided 2 into the expression there, the algebraic expression. So this y is going to go in there. So what is volume now? Volume is equal to x squared, and then 54 minus 1.5x. X, not y, x. So now I'm going to, that's a terrible x. I'm going to erase that and fix that, make it better. And x. So now I'm going to type this into the graphing calculators and find out the maximum volume. So I do have the volume in terms of x, so that just the x, the length of the side of the base is creating this situation. So I'm going to go to the graphing calculator. I've kind of preloaded some of this stuff. So here's the graphing calculator, and I'm going to turn it on. And I'm going to bring up the other screen so you can see it better. Let me get this out of the way. And view, detach LCD. All right, so I've typed the equation in, and I've already changed the window. If you just graph this on Zoom Standard, you'll never see the answer because the numbers are really big. So the window that I chose was between 0 and 50. Scale of 5, and I did 0 to 12,000 because the volume of this is over 10,000. And you could play around with the numbers and figure out that the volumes are really big, and I did a scale of 1,000. Okay, hit graph, and there's the graph of it. All right, so I'm looking for this maximum volume. So it's right here. So there's some x value over, and then some y value up. X would be the X of the side of the box, and then the output of it would be the volume. So I'm going to do left, right, guess under the calculate menu. So I go to Y, I go to calculate, calculate, and I'm looking for maximum, not minimum. I get to the left side, put the mark. I get to the right side, put the mark. And I go back and I guess the mark. So basically it's 24 and 10,368. So 24. So the answer is 24, comma, 10,368. 24, that's in inches, I believe. Is that the problem is in inches, right? That's inches, so it's 24 inches, so X can be 24. That's the most that X can be, and then the volume would be this many cubic inches. So that's quite a bit of space. All right, there's the practice test in all of its glory for chapter number 3. Thank you for watching, and I need to stop the video now. Click here, and stop.